This is the 2012 Capstone project by Brandon Epperson. And what we're going to be doing for this capstone is we're actually going to be doing a realization of an analog to digital converter that takes an input voltage that's scaled by a potentiometer and gives it to a binary readout that will be read from right to left. As you can see here, we have our initial design. It's complete also with a voltmeter inline to show an actual realization of the input voltage. Our initial voltage of input at 100% is going to be your 5 volts DC, and it's going to actually go into the voltage comparison side of the analog to digital converter, and the switch, which will be S1, will be acting somewhat of a pulse for the circuit, and with each pulse you should see a change in the binary readout in your probes in the upper right hand corner. Keep in mind the probes will be read from right to left. Now here we have, at 35% of the input voltage, you'll notice that the digital readout shows 1.75 volts DC. And if you read it from right to left on your digital word, with the unlit probes acting as zeros in the binary output, and the lit probes acting as ones in the binary output, for the 8-bit binary word we have 0, 1, 0, 1, 1, 0, 0, 1. And here we have, after the even with the pulse being in the off position, we have pulsed it at 100% of the input voltage, which is your 5 volts DC, and now you actually have the entire word, the 8-bit digital word, at straight ones all the way across the board. This allows for a maximum output of a decimal 255, or a binary representation of 8 ones in a row. And this is our breadboard representation of the ADC analog to digital converter with the 8-bit binary word output. If you notice the large component in the upper left hand corner, which is the large black box, if you're looking at it from a bird's eye view, that right there is going to act like your potentiometer. The analog to digital converter is the large blue rectangular object in the center with the various resistors and other outputs surrounding that. That right there is the realization of the capstone project for Brandon Epperson, student number G00072067, and I'd like to thank all of you for your time.